Today we're going to talk about trig identities, and we're going to start with the Pythagorean identity, which you probably recall from the last section, which is cosine squared plus sine squared equals 1. Now, cosine squared plus sine squared equals 1 can also be rewritten so that you have it solved for sine squared or that you have it solved for cosine squared, okay? So you have those options where you can rewrite them, which may be helpful as we go through when we start doing some proofs over the next couple of days. You can also take cosine squared plus sine squared equals 1 and transform it into two other Pythagorean identities. So one of them would be created by taking the original cosine squared plus sine squared equals 1. And if you were to divide all of these by cosine squared, you come up with a new Pythagorean identity. So cosine squared divided by cosine squared is 1. Sine squared divided by cosine squared is tangent squared. And 1 over cosine squared, hopefully you recall, is secant squared. We can do the same thing if we take cosine squared plus sine squared equals 1 and divide each by sine squared. And if we do that, we'd get cosine squared over sine squared, which is cotangent squared. Sine squared divided by sine squared, which is 1, and that's equal to 1 over sine squared, or cosecant squared theta. Okay, the next ones that we're going to review are the reciprocal identities, and these you should be relatively familiar with from our previous section. So cosine, sine, and tangent are the reciprocals of secant, cosecant, and cotangent respectively. So that means we know that secant is 1 over cosine. Therefore, cosine is 1 over secant. Okay. We know that cosecant is 1 over sine, and therefore sine is 1 over cosecant. Remember, the reminder we talked about in class was that there's one co per pair, cosine with secant, cosecant with sine, or S with C, C with S, so you can remember them. Cotangent is a little easier because it sounds just like tangent, so cotangent and tangent easily go together. So we have cotangent, which is 1 over tangent, and then we have tangent, which is 1 over cotangent. And then we can also express tangent and cotangent as a function of sine and cosine, which is often a useful strategy when you're solving or dealing with trig proofs. Okay, so we'll go ahead and take a quick reminder about tangent. Tangent is sine over cosine. So I'm just going to highlight that one because it's really pretty helpful a lot of times when we're doing proofs. And then, of course, if tangent is sine over cosine and cotangent is the reciprocal of tangent, then that means this is cosine over sine. Okay, we'll do one review problem, and we'll talk about two different options for dealing with example 1. Okay, first we're being asked to find sine, given that we know that cosine theta is 4/5, and we also know that sine theta is less than 0. So we know sine theta is negative. Okay, so most likely we are talking about quadrant 4, where cosine's positive and sine is negative. Okay, so one of the ways that we have done this problem in the past is that we would think about the fact that cosine represents the ratios of the sides of a right triangle. Okay, so if we're talking about cosine, that means adjacent over hypotenuse. And then we would be able to find the missing side in order to find sine, which would be opposite over hypotenuse. Now in this particular case, we know that this is a 3, 4, 5 triangle, so we know y equals 3. But if we didn't remember that this was a Pythagorean triple, we could of course use Pythagorean theorem, 4 squared plus y squared equals 5 squared, and solve. Okay, so now we know from this that sine theta is equal to negative 3/5. That's option 1. Or, now that we know the identities, we could use the fact that sine squared plus cosine squared is equal to 1. Okay, if we use that, we can sub in what we know. We know cosine is 4/5, so we can say 4/5 squared, and then we have our sine squared. Okay, so what's 4/5 squared? That's 4 squared over 5 squared is equal to 1. And then we'll just solve for sine squared, right? So that means sine squared theta is equal to 1 minus 16 over 25, which would be 9 over 25. Okay? And then we would take the square root of each side. So if I take the square root of sine squared, I just get sine theta. And if I take the square root here, I technically get my plus or minus square root of 9, square root of 25. So I get my 3/5. Now this is where the piece of information about it being sine is less than 0 is important, because then we would say that this is sine theta equals negative 3/5. Okay? So either way, I get the same accurate answer. So the question is, well, does it matter which way I do it? Absolutely not. What matters is that you know at least one of the ways of dealing with it. Okay? I'm going to ask you to go to the next page. And on the next page, there's an example 2. It says, use established identities to express the following expressions as a single function or a constant. So you're going to go ahead and re-express what's given using the identities from the previous page. So remember in class, I said that that previous page is sort of like the cheat sheet for your proofs. So you can use that to remind you of some of the formulas. So in this case, secant can be rewritten as 1 over cosine. Sine is, we can just leave as sine if we want. And then cosecant is 1 over sine. So since these are all being multiplied, any numerator can cancel, reduce to 1, with any denominator. So I'm really left with 1 over cosine, which is the same as secant theta. So I didn't really need to change the secant, but one of the tips we'll talk about in the next video for dealing with proofs is that you would change things to sine and cosine. In this case, it wasn't as helpful. Okay, I'd like you to try example 2.